solving systems of equations with graphing, which is great. This feels so close. I'm going to make it less close. Hey, check out the ceiling. And then look at me again. There we go. Now we're less close. Okay, so we've been solving systems of equations for graphing, which is great, right? It works, and wherever the two equations cross, that's the solution. But solving system of equations with graphing has problems. Who can tell me a problem with solving systems of equations with graphing? What's the problem with it, Jaden?
You could miscount your lines, like if it's a decimal.
What if you graph wrong? Or, oh, hello, wrong. Or what if you have a fraction answer? Do all systems of equations land on beautiful, perfect numbers?
No.
No. The ones I've given you have because you were graphing them. But like, let's say that this is your graph, right? And you've got this going on. And you have two lines and they meet precisely right there. What point is that?
I don't know.
There's one and change. One and 2/3 and 2/3. I don't know. Can I be very precise with that?
No.
Do I have I have a clue? I know it's one and change and then some fraction, but I don't know what it is. And I kind of like precise numbers, right? What's another problem with graphing? What's another problem with graphing, Boston?
You might not want to draw a graph.
I might not want to, but graphing takes time. And how many of you wander around with graph paper in your back pocket all the time? Really? I think you lie. I think you are full of lies. You don't wander around with graph paper in your back pocket, you little liar.
This is all forgot some though.
Oh, wow, there is weather happening outside.
It's starting to snow.
Is that snow or is that hail?
Snowy
I think that's hail, guys. Well, there's. Okay, do we need to close the windows so the math can happen?
No.
Okay, we have acknowledged, weather. Let's go back and do some math. So graphing is not the best way. I'm going to be honest with you. There are times in my life that I encounter systems of equations. Mostly, it happens in science, right? It doesn't really happen in my daily life. I'm up brushing my teeth. Oh man, 2x minus 3y equals. That doesn't happen. But in science, you do have systems of equations. It happens. How many times have I solved, outside of 8th grade math class, how many times do you think I have solved a system of equation by graphing?
A couple times.
Exactly 0. Never have I ever. Because it's the most cumbersome and ridiculous, and you get one fraction in there, and it's all over and you're screwed. So we're going to teach you how to not do it with graphing. I'm going to teach you a method today. I'm going to teach you another method on Monday. And I use them. It depends on the equations that you have, which one you use. There's different methods that work for different ones. So I'm going to show you an equation here. Okay, I'm just going to write down a random equation, and the equation is x minus y equals 3. Can I solve a single equation with two variables? Do I know how?
Yeah. No.
Do you know how? I mean, I could graph this and get an infinite number of answers, but I want one answer. I can't do it. It doesn't exist. Okay, so from a mathematical standpoint, is it legal for me to add 10 to both sides of this equation?
No.
Who says no? Why can't I add 10 to both sides of the equation?
Because there's no 10 in the current equation. Yeah.
No. Okay, can I add anything to both sides of anything? Yeah. Legally, as long as I do it to both sides, I could add 1,000,000 to both sides of the equation. I could divide both sides of the equation by 2,654.25, and it would not mathematically be wrong. You might be saying to yourself, Mrs. Barlow, why in the world would you want to add 10 to both sides of the equation? But that's not the conversation we're having. Is it legal to do that?
Yeah.
It is completely legal to do that. I could add 10 to that side of the equation, and I could add 10 to that side of the equation. And as long as I do it to both sides, I could do that all day long, and the math police are not gonna tell me that it's wrong. Okay, now what if I tell you equals 10. Okay? I just said that I can add 10 to this side of the equation and this side of the equation is completely mathematically legal, right? So I'm going to add 10 to this side of the equation, and I'm going to lower this down a little bit because I write big. I'm going to add 10 to this side of the equation. I am also going to add 10 to this side of the equation, but I'm not going to add this 10. I'm going to add this 10. Because this 2x plus y is what? 10. So I can add 10 to this side of the equation, and I can add 10 to this side of the equation. Do you guys see how I did that? 2x plus y is 10. So I can add 10 over here, and I can add 10 over there. From a mathematical perspective, is that legal? And you're going to see it's also handy. Because let's see what happens when I add 10 to both sides of the equation. But this 10 looks like 10, and this 10 looks like 2x plus y, but it is 10, because I know that because the equal sign told me so. So what's x plus 2x? What is it, Cheyenne?
3x.
3x. What is negative y plus y?
0.
0. And what happened to my y's?
It disappeared. Goodbye. Bye.
It just zeroed itself away from my life. And then that equals, my equal sign just comes down like normal. And then what's 3 plus 10?
13.
13. Well, that was supposed to end up prettier than it did, but that's okay. So, did I add 10 to both sides?
Yeah.
Is this something I can solve?
Yeah.
Can I find out what x equals?
Yeah.
Yes, I can. I can find out what x equals. So how do I find out what x equals? Divide. What am I doing to do, Jaden?
You're gonna divide both sides by 3.
Divide both sides by 3. And I get x equals 4.3 onto infinity. What do I do with this now? I have x. That's great. Do I have y?
No.
Can I use this to find y?
Yes.
How would I do that? How do I do that, Jaden?
You would take the number that you got from the equation
Okay.
and minus. Wait, no, you would minus it by x, but in this case, we're gonna add x to it.
Okay. Not quite. Cheyenne, what do you think?
You're turning the equation into slope intercept.
We're not going to graph it. We're not graphing it. So
don't
it doesn't
want
have to be a slope intercept. Do you see graph paper? No, we're not graphing this. Bob, what might I do?
Substitute it in.
Substitute it in. Do I have an equation out here that uses an x and a y?
Yeah.
Yes. Do I know what x equals?
Yeah.
So I'm going to substitute it in. X is 4.3. So I can say 4.3 minus y equals 3. Do you guys see that? Well, 4.3 minus what equals 3? 1 and 1/3. 1.3 or 1 and 1/3. Do you see how that works? So, x is 4.3, y is 1.3, and I'm just rounding here, and I'm done. What would have happened if I had graphed this? Would I have been able to get a decent answer? No, because we've got a fraction, we would look at that and go, I don't know, maybe that's 0.3, maybe that's 0.4, maybe that's 0.2. Could you tell by looking? Yeah. You couldn't tell by looking. And so it's a really, really nifty way. Let's try a couple from your assignment. Because sometimes they're beautiful like this, sometimes they're not. So, whenever I have two equations that I could see could add together and cancel out, I use this method. So on example 1, this is example 1 on your assignment, I have 3x plus 6y equals 12. And I have 4x minus 6y equals 2, okay? So I'm going to take this equation here and I'm going to add 2 to both sides. This is 2 and this is 2. So it's completely legal to add one side of the equation to one side and one side of the equation to the other side, okay? So I have 3x plus 4x is what? What is it, Clara?
7x.
7x. 6y minus 6y is what? 0 goes away. Bring my equals down. And then 12 plus 2 is what? 14. And what does x equal?
2.
X equals 2. Am I done? No, because I don't know what y equals. So which equation should I substitute x into to figure out what y equals?
Number 1.
The top one?
You guys are all saying the top one. Could I do the bottom one if I felt like it?
Yeah.
Does it matter?
No.
It does not matter. I'm going to choose the top one. You know why? Because 8th graders tend to be allergic to negative signs.
Yep.
You guys just avoid them like they're peanuts or something. So we're going to not choose that one. But could I if I felt like it?
Yes.
Totally I could if I felt like it. Neither one is wrong. So 3x. So we have 3 times x. But what does x equal?
2.
So 3 times 2
6.
plus 6y equals 12. And somebody was telling me 3 times 2 equals 6. So we have 6 plus 6y equals 12. How do I deal with this? What do I do next? What's my first step on this equation? Let Emma.
Get the 6 to the other side.
How do I do that?
Subtract it.
And this 6, right? Not this 6.
Yeah.
So minus 6. So we have 6y equals 6. How do I deal with this 6? Tricia, how do I deal with that 6?
Wouldn't you divide it?
I would divide it. Thank you for telling me that and not telling me to subtract it. I am seeing if I can go the whole day with nobody telling me that subtraction undoes multiplication. So far, we are in 4th period and nobody has told me that subtraction undoes multiplication today. So, what's 6 divided by 6?
1.
So what does y equal?
1.
And then we have the point 2, comma 1. If I was graphing this, where would they cross? Where would they cross, Ellie? At 2, comma 1. Now, that's a nice, pretty number. Are they all going to be nice and pretty?
No.
No, but this one happens to be. Let's look at the next one. So we're going to have example 2. So we have 8x minus 2y equals 16. And we have x plus y equals 10. Oh dear, we have a problem. What happens if I just straight up add those?
Bad things happen.
The y's don't go away, the x's don't go away, nothing goes away.
No.
No!
I guess.
So what do I do? Do I just go find somewhere and cry? What do I do, Eli?
You add like 2 full size?
Well, adding 2 wouldn't help.
I don't.
Bob, what do you think?
Force one to disappear by making it equal the other.
How do we do that, Kayanne?
You multiply the bottom problem by 2.
Okay, what happens if I multiply? Can I multiply everything on this bottom problem times 2?
Mm-hmm.
From a mathematical standpoint, is that a legal thing to do?
Yeah.
Yeah. So 2 times x is
2. 2x.
2x. 2 times y is
2y.
2y. And 2 times 10 is 20. Now, if I add these 2 together, what happens to the y's?
They evaporate.
They disappear. They mathematically, boom, and they disappear. So sometimes it'll be beautiful and perfect. And sometimes it will be almost beautiful and perfect. Either way, I still use this method. This is a great method for solving systems of equations. If your equations that are at all similar and you can multiply one by something to equal one of the terms of the other one, do it. This is one of my favorite ways of solving systems of equations, okay? So let's add them, see what happens. What's 8x plus 2x? 10x. What is negative 2y plus 2y?
0.
0. Goodbye. And that equals, what is 16 plus 20?
36.
36. Okay, is this going to be a super duper pretty answer?
No.
It is not. Can we deal with it anyway? Sure we can. So how do I get rid of that 10, guys? Divide by 10. None of you told me to subtract. I'm so happy. Okay, so x equals 3.6. I'm going to I have now 3 equations I can choose from. This one is legal. this one is legal, and this one is legal. Which one do we want to choose? I'm going to use the middle
Yeah,
one.
it's nice in middle. Let's do middle.
Because like there's the least happening with that one, right? So honestly, it's the least amount of work for me. So x is 3.6. So I'm going to say 3.6 plus y equals 10. How do I get rid of this 3.6?
You
Subtract it from both sides. What is 10 minus 3.6?
6.4.
6.4. So we have the point 3.6, comma 6.4. Can you guys, can you imagine graphing that thing? That'd be horrible. And you're trying to, you're whipping out your little magnifying glass to see, okay, there's 0.4 and there's 0.6. And this, no, just no. But this way, can we get a beautiful solution?
Yeah.
This is a great way. This is honestly one of my favorite ways to solve systems of equations. You have 6 to do on your own. It's not that many. Most kids finished in first period. You can do this.